MAP4C, day 3. This is lesson 1.1b on solving problems in right triangles. Today's 3-minute review goal is actually the stuff we did yesterday to use SOHCAHTOA to find unknown sides and angles in right triangles. And this one's not exactly a review from yesterday because we haven't had one just exactly like this yesterday. It asks us to solve triangle XYZ, and hopefully you might remember from grade 10 or grade 11 what solving a triangle means. Solve means to find everything about a triangle. I got to find all the sides and all the angles, and I got to keep working until everything is known. So let's just list off the stuff we need to find. So angle X is okay. Angle Y is not known. Angle Z, need to find it. Side X is okay. Side Z is okay. But side Y we want to find. And I'm just going to, we got to keep working until all these are known. I'm going to start with angle Y. So there's angle Y. And for angle Y, I have to figure out which sides that I'm given. Across from the 90-degree angle, that's the hypotenuse. This is the adjacent side. And so the adjacent side and the hypotenuse, adjacent and hypotenuse is the cosine. So cos Y is adjacent over hypotenuse, which is 8.2. And then I'm going to want to do this. And yesterday we actually put that in the calculator and then did the inverse cos of both sides in 2 steps on our calculator. I'm going to see if we can save a step on our calculator here. We know we're going to have to take the inverse cos. That we're going to have to do this, but this is a decimal number yesterday. Let's see if we can do this in 1 step in our calculator. 6.0 over 8.2. The bracket should be more like that. But we got to practice putting that into our calculator in 1 step. And it kind of depends on what type of calculator you have. And if you have an older calculator like mine, it's kind of like this one here. This one, you kind of got to do the inside thing first and then the trig stuff on, second. So let me show you what I mean. If I go 6.0 divided by 8.2 and press equals, and that we normally, like yesterday, we write that number down. And now I got to do the inverse cos of that. Inverse cos, about 43 degrees. A lot of you have a newer calculator, better calculator, and they actually behave kind of like the graphing calculators here. So I'm going to show you how it's nicer on these. Most people have calculators like this where when you hit something you can actually see it as you hit it instead of it building up in the calculator memory or whatever. So I'm just going to type in exactly what I read and it's going to do it for me. I see that I want the cos minus 1, so second function cos, and I can see that right away, cos minus 1, 6.0 divided by 8.2, end bracket, and I press enter, or equals, and there's the 43 degrees. 1 step on the calculator, so that's kind of nice. Save a little time. And I could do something, moving on to angle Z, I could do something similar for Z, but I've got that angle. I now know that that angle is 43 degrees, so I could just use the angles in a triangle or 180 and figure out what Z is, right? It's 180, subtract the 90-degree angle, subtract the 43-degree angle we just found, and that's 47. Lastly, side Y, and we could use trig to find side Y, but it's a right angle triangle and we've got 2 of the 3 sides, so we could use Pythagorean theorem, and that's what I'm going to do just for fun. Hypotenuse has got to go on one side by itself, and then a squared plus b squared, and I'm just substituting straight into this formula too, and then we get this into our calculator. Probably some of you that are slick with your calculator could find ways to save some steps here too, probably. Now I got to subtract 36 from both sides. you don't have to show that. That's just so you know what I'm doing. And then finally, to get y, we got to take the square root of both sides. From here to here, the operation that I did is square root. And I got 5.6. Hopefully you got the same thing. And that's it for the 3-minute review. That's how we solve triangles. And I'm pretty sure today's homework has got one like that, just for you to practice solving triangles. Other problems that we can see in today's lesson are to solve real-world application problems. And a lot of these real-world application problems have this idea of the angle of elevation or inclination and the angle of depression, right? Where somebody's looking up at something or somebody's looking down at something and an angle is created, right? And the problem that math students have is they always goof it up, and they get the wrong angle. Like, where's the angle? Is the angle here or down here or over here? Where's the angle? Well, hopefully we can get that straight. It says always measure the angle of elevation or depression from, this is the horizontal. Wherever horizontal. Wherever you are in the question, or wherever the person is in the question. So, somebody's down looking up at a lighthouse, and it says the angle of elevation is a certain angle. Well, there's the horizontal, and then up from the horizontal, that's the angle of elevation. So this angle right here, that's the angle of elevation. Similarly, if I was in the helicopter and I looking at a sailboat out at sea, the angle of depression, looking down, that's depressed, right? Your head goes down. The angle swept out there, that's the angle of depression. This one right here. Always from the horizontal. So that right there, that's the angle of depression. Now you're probably wondering, how in the world would you actually get those angles? If you're in a helicopter, how would you do it? Right? How would you know that, angle of depression is 30 degrees or the angle of elevation is 45 degrees, whatever? Well, there's a way. And maybe some of you did this in grade 10 or 11. But this is a little device. It's called a clinometer. You don't need to write any of this down. It's just for your own knowledge. And this is a homemade one, where there's a protractor and a straw and a string, and essentially you get your protractor and straw and string, and you look up, and that angle that's made right there, how much you've tilted the straw up or down, the clinometer, is the angle of elevation in this case. There's some more fancy ones. This one's a little fancy. You might see this in the science class or something like that, and this might be one that they use for surveying or something. It looks like it might be digital. Pretty fancy. But this is possible to do this sort of thing. Another application, another spot where we find trig problems is this idea of bearing. We talk about bearing when we're talking about ships at sea, boats, that sort of thing. Sometimes surveying. It's a term that refers to the direction in number of degrees clockwise from north. So you see straight north here, right, like this, that's 0 degrees, a bearing of 0 degrees. And then the angle, the direction that you're heading at is, an angle from that spot all the way up to 360 degrees. We see all the way around would be 360 degrees. So if this is north, straight north, what's the bearing that this sailboat is on? Well, you say, well, it's 40 degrees. No, it's not 40 degrees, because 40 degrees would be over here. This angle is on a bearing of all this distance, clockwise rotation from true north. Well, what is that? Well, all the way around would be 360. So it's everything but 360. So this boat's on a bearing of 320 degrees. And we'll have an example like that one in the examples. All right, finally, example. From the top of the CN Tower, the angle of depression of the Rogers Center is 73 degrees. Find the horizontal distance between the two. So we see angle of depression angle, we got some sides, and we want to find one of the unknowns here. Well, the best thing to do is start with a diagram, right? And then we'll get an idea of, where the angle is we want to find. And I know some of you will draw some great diagrams here, but there's my CN tower. There's my Sky Dome, or Rogers Center, whatever they call it these days. It says from the top of the CN tower, the angle of depression of the Rogers Center is 73 degrees. So where's that angle? Well, we can sort of see there's the looking down, but where does the 73 go? Well, if we're on the top of the CN tower, it's always measured from the horizontal, and it gets swept out from there, right? Horizontal, that angle there is 73 degrees, right? Now, we said, what's the thing that we want to find? We hope that this CN tower is going straight out of the ground, that it's a 90-degree angle. I think we want to find the horizontal distance between the two. We want to find this, where the height of the CN tower is 213 meters. Right? Well, notice that angle isn't in our triangle, right? So there's a couple of ways to do this. One is you can see that this is 90 degrees here, so I could just go 90 minus 73. That's 17 degrees. This little angle in here is 17 degrees, and now we've got an angle in there. Other people might say, well, I remember my parallel line rules, and there's a Z pattern, right? There's a Z pattern. I could get that that's 73 degrees by the Z pattern. Yeah, sure, whatever. Any way to get an angle in that triangle will be good. And there's probably other ways to solve this problem as well, but I think we've got the idea. So I'm going to use the 17-degree angle. That's the one that occurred to me first. So from the 17-degree angle, this is the opposite side. This is the adjacent. This is the hypotenuse, because the 90 degrees is pointing at it. Opposite and adjacent. So I'm going to use, which one am I going to use? Opposite and adjacent, I'm going to use the tangent. So the tan of 17 degrees is opposite over adjacent. Solving for x, all I have to do is get rid of the 213. Opposite of dividing is multiplying. 213 tan 17. Put that in my calculator in one step. I hope to do that, and looks like it's about 65.1 meters. So they're actually fairly close together, and if you've been there, you know that they're not that far apart. Have to answer a word problem with a sentence, right? The two are 65 meters apart. You can write better sentences than me, and neater, obviously, too. And notice no unit conversion on this one, just good old, plain old trig. All right, next. Okay, I think this question is a little bit different than the one that's on your sheet. It starts off the same. Captain Ferd sails due east from harbor for 10 miles, and then I think yours says, then changes his bearing to due south. I think that's, and we're going to stick with what you've got on yours. So this is supposed to say due south. He continues to sail for 14 miles. What bearing should he set to head for home? This is that bearing idea. How far must he go on that bearing? All right, well, here we go. First step of the solution. Solution. S-O-L apostrophe N, solution. Draw a diagram, right? Let's draw a diagram. So due east, straight east is this way, right? Notice that if we're talking bearing, I don't want to get too technical here, because we know we're headed this way, right? That's due east. But if it was a bearing, due east, the way that we're going is actually a bearing of 90 degrees, right? Because straight north is 0. Straight east would be a bearing of 90 degrees. So I don't know why we would say a bearing of 90 rather than straight east, but that's why it probably says due east in the question. And that's for 10 miles. Okay, and then changes his bearing to due south. I'm going to start traveling south then, and that's for 14 miles. It's black again. Notice that if we had, what bearing would be straight south? Well, north is 0, so south would be, well, what would be the bearing going straight south? 180 degrees would be the bearing, right? That would be this idea of bearing. Okay. What bearing should he set to head for home? Well, he wants to go back home. That finishes off the triangle, doesn't it? And there's a triangle. We see. Head straight home. So we kind of have to find this angle, don't we? Where east and south make a 90-degree angle, and so we want to find that angle. Notice that angle is actually not going to give us the bearing. We'll have a little more work to do than that, but that's the opposite side. That's the adjacent side. Again, the hypotenuse we're not using. It's over here. We're not using it. Tangent. Good old tangent. Very useful tangent. And notice I'm using theta, a Greek letter theta for my angle. You can use anything you'd like, X or M or Z, whatever you'd like. I'll use theta because it's, I don't know, smart, fancy, whatever. Opposite 10, adjacent 14, and now I'm going to do the inverse tan of that. Again, I'm going to try and do this in one step to save a little time and effort. Pound that into a calculator. The inverse tan of 10 divided by 14 is around 36 degrees. So this angle is 36 degrees, but what's the bearing? Remember, the bearing would be, if we set up, let me get a different color here just so we can, if we set up the little northeast southwest thing, there's straight north. If we headed back north, that would be 0. And so the direction that we need to head on is actually almost all the way around, isn't it? It's the 360 minus the angle that we needed. So the bearing is 360 minus 36, which is about 324 degrees. The bearing should be 324. What's part B? How long is he going to sail for? Well, he'll sail until he crashes back into the dock, right? Well, and not in math class. We got to figure it out. And again, we could use this angle and trig, or we could, use the Pythagorean theorem. This is the distance that he needs to find. It's the hypotenuse. This is no big deal. 10 squared plus 14 squared, pound that into a calculator, is 296. Square root 17.2 miles. Ferd will sail for 17.2 miles. Now, notice maybe this bearing stuff is the only thing that's new. These problems are stuff we've seen in previous years. So I'm hoping everyone's happy and is ready to do some homework. I think that's it.